Hello, welcome to Introduction to Composites. Today is the last day of the ongoing week, and till so far we have been discussing different types of fibers which are used in composite materials, and we have come across glass fibers, graphite fibers, metal based fibers, fibers made from high performance polyethylene fibers, ceramic fibers, and several metallic fibers. Now, all these fibers are embedded in a matrix material. So, the performance of the overall composite is not only strongly dependent on how apt and appropriate the fiber is to me in context of our needs, but also how apt or appropriate is the matrix in context of our needs. And to explain that, we have to think about it a little more carefully. So, we will discuss as to what is the exact role of matrix material in context of the efficiency of a composite material. So, let us see what does a matrix material do. So, we will discuss matrix materials. So, what does it do? So, if you have a bunch of fibers, by themselves what can they do? The first thing is each fiber is very thin. So, because the cross sectional area of fibers is very less, you cannot load the fibers by themselves because they are very thin. You cannot grip them and load them. They cannot be loaded. This is a practical problem. You cannot catch them and pull them easily. Okay? You need very special complicated devices. So, this is one limitation. The second thing is fibers without matrix are isolated, are mechanically isolated in absence of matrix. Okay. So, what does that mean? They cannot transmit load between themselves. They cannot transmit load between themselves. So, it could be that, so why is that important? Why do we want loads to be transferable? Suppose you have just four fibers and each of these guys you are pulling you are pulling it in such a way that you apply the same force on each fiber, and let us say this is thicker, fiber 1 is thickest, second is slightly thin, third one is even thinner, and fourth one is thinnest, and you are applying same force to all fibers, same force to all fibers. Now, because one is thickest, it will tend to extend the least amount, and 4 is thinnest, it will tend to extend the by maximum amount. But because the ends are constrained in like, they have to extend by the same amount. So, what you really have to figure out is how do you transfer extra load from here to this guy, so that the entire thing has uniform displacement, right. So, we need for efficient design of structures a mechanism to transfer load between fibers, and this transfer cannot happen if there is no matrix. So, matrix does these two things at a very fundamental level. It binds all the fibers together, so you have a physical shape of the composite, it helps you grip and apply load because everything is now connected, and it helps you transfer loads between different fibers so as to make the overall system much more efficient in terms of load transmission. So, this is what a matrix does. So, let us see again what are the important functions, because once we understand this, then we can start figuring out which particular matrix will be good for us. So, this is important. Functions of matrix materials. Functions of matrix materials. First function, it binds the fibers together. And that provides the overall composite to come together, otherwise you have just individual parts. Second, it transfers loads and stresses between fibers, okay, transfers loads and stresses between fibers and between the composite structure. Third thing, it supports the overall structure. So, we cannot think that matrix is less important. These are very important functions. Matrix is equally important. Fourth, we know, for instance, some fibers are very sensitive to moisture. Yeah. So, it protects composite from external agents. For instance, chemicals, moisture, and so on and so forth. And the last one is, it protects fibers from damage due to handling, like we saw in case of glass fibers, they can abrade each other. So, these are very important functions of matrix materials. So, whatever we choose, we have to make sure that all these things happen. If all these things are not being performed by a matrix efficiently, then it is not a good matrix material. Okay. So, some important points, important comments. So, one is that important comments about matrix materials. So, this is from a functional standpoint, but there are some other things which matrix has a very strong influence on. So, what does it influence? In unidirectional composites, matrix strongly influences what? Transverse modulus, transverse strength, shear modulus, shear strength, shear strength. I will explain that. There are several other points, but this is important to understand, and we have to all start getting used to all these terms like transverse modulus, shear and things like that. So, consider a composite which is made up of fibers and it is embedded in a sea of matrix. Now, typically the Young's modulus of fibers is very large compared to that of matrix, and also the strength of fibers, the tensile strength of fibers typically is very large compared to that of matrix. So, if I pull this composite in this direction, and let us say this apply Fx, then it will be the fibers which will decide how much extension the composite is going to experience, because the fibers are much more stronger and much more stiffer than matrix. So, fibers are going to decide what is going to be the overall extension and whatever is going to be the overall strength. Okay. So, in the direction of fibers, if I pull it, I will get an idea what is the longitudinal strength and longitudinal modulus of the composite, and that is being predominantly going to be decided by fibers, especially if there are very large number of fibers. But the same is not true if I pull it like this. If I pull it in the y direction, the fibers do not have a tendency to stretch, it will be the matrix which will decide what is going to be the transverse modulus and transverse stress of the system, just based on this physical understanding. The mathematics and all that we will discuss later. But so, if we want the material to be stiff and strong in y direction, it will be predominantly decided by the matrix. So, we have to choose matrix correctly. Similarly, if we have a composite, the same composite, if we want it to be strong in the shear sense, in the shear direction. So, this one is I will say Fxy. The shear modulus and the shear strength also of the system will be predominantly influenced by matrix. So, this is important. So, matrix for structural reasons also is very important. Its job is not only to do all this good stuff, binding the fibers, transferring load, supporting the structure, but it also for unidirectional composites, it has a strong role in influencing transverse modulus, transverse strength, shear modulus, shear strength. Let us see what other things it is very important for. Matrix decides maximum operating temperature, because in most of the in a lot of cases the fibers can take a lot of temperature. Glass fiber can take a lot of temperature, graphite fiber can take a lot of temperature, boron fibers can take a lot of temperature, ceramic fibers they can take a lot of temperature, HPP may not be at the appropriate size, but most of the fibers can take a lot of high temperatures. But if the matrix is some plastic which starts becoming soft at 150, 160 degrees centigrade, the overall composite's operating temperature limit is going to be decided by the matrix. So, this is another thing. Then another important thing to note is that in general most matrix materials, so we are not talking about some special matrix materials such as metal matrix systems as in cements. Most of the times metal matrices are made from polymers like epoxies, polyesters, PEEK and things like that. So, in general most matrix materials are light, flexible, weaker relative to fibers. Okay. So, we have to bear this in mind when we are designing the overall system. So, this is very important. Classification. Classification of matrix materials. So, broadly speaking, there are 4 classes of matrix materials. So, the first class is polymers. Polymers, they are organic compounds, long chains, and matrices which are based on polymers, they rarely perform above 200 degrees centigrade. So, operating temperature range, so they rarely, so it is usually less than 260 degrees centigrade. So, if your application range is room temperature or general up to 100, 120, or if you use a really fancy matrix, polymer matrix, maybe you can go up to 250, 260 degrees centigrade, but not more than that, then you can use polymers. So, it is the temperature which is a very strong influencer as to what type of matrix you should use. Second one, then you can use metals as matrix, as matrix materials. So, if you want to increase your operating temperature limit, the next choice is metals. Okay. Here the range is from 260 to 750 degrees centigrade. A good example of a metal matrix example would be aluminum. I mean, in some ceramic metal composites, sometimes aluminum is used as the matrix because it is light. Okay. So, this is there. If you have to go even higher than 750 degrees centigrade, think about it, what materials do not break above 750? So, that could be glass. Okay. Glass. So, glass allows you to go up from 750 to 1150 degrees centigrade. The good thing about metals is that they are not brittle in general, they are ductile. But if you use glass as a metal as a matrix material, then you have to make sure that you do not apply in applications where you it can become brittle. Okay. So, if you have high impacts and things like that, then this can crack. So, you do not want that. So, but then glass can get you up to 1150 degrees centigrade or so. And then finally, you have ceramics and carbon. So, this can go from 1150 to 1400 degrees centigrade. Okay. So, these are different classes of matrices and we have classified based on their operating temperature range. When you are planning to use carbon as the matrix, it is very important to remember that at higher temperatures, if you have a piece of carbon and you have oxygen, it will burn. So, you have to make sure that if carbon is the matrix material and temperatures are pretty high, then you have to somehow protect it from oxidation. So, you have to coat it in something which is still stable temperature wise and it does not react with carbon and it protects it correctly. So, this is very important thing to consider. So, with all this information, finally, we will look at some of the important considerations which are required while we are choosing the matrix material. So, considerations. while choosing matrix material. So, there are several considerations, they are not in any particular order, but these are some of the important considerations. First one is specific gravity. Do you want your material to be light, or weight is not going to be a big consideration? So, specific gravity. So, for that reason, if I have to have a very super light application, maybe I do not want to consider metals as the matrix material, because even aluminum, which is one of the lightest metals, it has a density of about 2.8 compared to polymers where the density is about 1 or 1.2. Second thing is we have to look at the mechanical properties of material. So, what does it mean in mechanical properties? Young's modulus, ultimate tensile strength, CTE, thermal conductivity, and so on and so forth. Okay. Now, the third one is very important, melting temperature. Now, some matrix materials do not have a melting temperature. For instance, some thermoset polymers, they do not. So, you heat them and after a certain point they will just decompose. So, either you can consider melting temperature or the decomposition temperature of the material. So, that is there. But another thing is curing temperature of matrix, because a lot of polymers, when they are in initial state, they are in fluid state, liquid state, and then you mix them with some compounds, you raise the temperature, and then at an elevated temperature they solidify, and at that elevated temperature, because they solidify, thermal stresses get logged into those types of things. So, curing temperature has a strong relationship with the thermal stresses which are logged in the composite and also in the matrix material. So, that is why this is important. The next one is viscosity, because, so why is viscosity important? Suppose you have fibers and then you want this matrix material, you want matrix material to flow like this. A material which is extremely viscous will not flow between the fibers very easily, and as a consequence fibers will be, at some places they will be wet, but at other places they will remain dry, and where they remain dry they will remain unconnected with the overall system. So, there will be internal cracks. So, for processing related reasons, viscosity is a very important parameter. So, you have to make sure that whatever is the viscosity, it does not create problems like this. Then you have reactivity with fibers. You really do not want your matrix to react with fibers, they should be mutually inert with respect to each other. Then reactivity with ambient environment. So, it could be that you are going to use your composite in seawater, so you have to make sure that your matrix does not react with seawater, or in air or in nitrogen, whatever. And then of course, the last thing and very important thing is cost. So, these are some of the very important considerations when we are discussing about matrix materials, and this I hope it gives you a overview of what the whole world of matrix material looks like. Starting next week, we will discuss different matrix materials in terms of their physical properties and what are some of the specific applications of these different materials. And once we are done with matrix materials, then we will move into the next phase as to how composites are fabricated. So, matrix materials, fabrication of composites, that is something, those are some of the two topics we plan to touch upon next week. So, till then, have a great time, and I look forward to seeing you on Monday, which will be the week 3 of this course. Thank you.